continuing on our path of synthetic division, and just going back to what we reviewed in Unit 4, a root, if you'll recall, or a zero, of a polynomial is any value that makes the polynomial equal 0. So if x minus a is a factor of a polynomial, then a is a root of the polynomial. And if x plus a is a factor, then minus a or negative a is a root of the polynomial. So if I had factors of x minus 3 and x plus 2, that would mean that my roots would be positive 3 and negative 2. And it's always the opposite sign that's important to remember. So there's a theorem that says a number a is a root of a polynomial if and only if, when dividing the polynomial by x minus a, the remainder equals 0. So how does this tie into synthetic division? Well, we learned how to do synthetic division in the last unit. And if you'll recall, whatever the number was in front of x squared, which is a 1, went here. That's where this 1 came from. The negative 2 in front of x was here. And then the minus 3 that's at the end was here underneath the radical sign, I guess you could say. And then you take whatever you want to know if x minus 3 is a factor, so you always switch the sign. And you do your synthetic division. So you bring down the 1, then you multiply 3 times 1, and that's where that 3 comes from. And negative 2 plus 3 is 1, and you multiply 3 times 1, and you get 3, and negative 3 plus 3 is 0. So here's the thing now, is that we've taken this, and we've learned how to do synthetic division last time, so now we're talking about what happens when you get 0. If you get 0 as your remainder, if you get a remainder of 0, then what that means is that x minus 3 is a factor and x equals 3 is a root. So because I got 0 here, only because I got 0, that told me that x minus 3 was a factor and x equals 3 is a root. So you can use synthetic division to simplify a polynomial. And if you get a remainder of 0, the divisor is a factor. And that means that the negative of the divisor's constant is a root. And that's basically what we said over here. It's the same thing. We're just putting it in vocabulary terms and more generic terms. So there's this theorem called the remainder theorem. And the remainder theorem says that when a polynomial in the form f of x, so in f of x equals whatever, is divided by x minus a, then the remainder is f of a. So putting that into words, because I think that will help, is it's saying that if I had a polynomial like the one we have up here, if I wanted to know my remainder ahead of time, I can plug this in, or the opposite of that, into the function. So I would be replacing all the x's with a positive 3. So I would do 3 squared minus 2 times 3 minus 3. Well, 3 squared is 9. 2 times 3 is 6. And then minus 3. 9 minus 6 minus 3 is going to give me 0. Well, the remainder theorem says that whatever you get here when you plug it in is the same thing you'll get here when you actually do synthetic division and calculate and get the remainder. So if I wanted to know what my remainder was when I divided x squared minus 2x minus 3 by x minus 1, then all I have to do is plug in positive 1 for all of my x's. So remember, my original equation was x squared minus 2x minus 3, and they've gone ahead and they've replaced each of those x's with a positive 1. It's always the opposite. So 1 squared is 1, 2 times 1 is negative 2. Minus 3, and 1 minus 2 minus 3 is going to give me negative 4. So that means that if I were to divide x squared minus 2x minus 3 by x minus 1, it's not a factor because I didn't get 0. It's going to give me a remainder of 4. And I could prove that by doing synthetic division if I wanted to. So there's this theorem, also, there's another theorem called the rational root theorem. The rational roots of f of x, of a polynomial, can be written in the form of p divided by q, where p is a factor of the constant term of the polynomial, and q is a factor of the leading coefficient. So what they're saying is that we call this number here, that's where we get our q's from, and this number here is where we get our p's from. So what this is telling us is that if we take all the factors of -2 and 3 and we put them in a fraction form, we're going to get all of the possible roots. So rather than there being a million options for roots, we can narrow it down to maybe 10. So if I start off with -2 and I'll list out all of my factors of -2. Well, I can divide -2 by 1 and I can divide -2 by 2. And that 1 can be positive or negative, and that 2 can be positive or negative. And if I think about my q's, which come from my 3, I can divide 3 by 1 or by 3, and again, it can be positive or negative. So what that means is that my possible roots would be, I just divide. 1 by 1 is going to give me 1, so positive and negative 1. 1 by 3 is going to give me 1/3, and so it'd be positive and negative 1/3. 2 by 1 is going to give me 2, so positive and negative 2. And 2 by 3 is going to give me 2/3, so positive and negative 2/3. So rather than trying to guess at what my roots could be of this function, I can narrow it down to one of 8 numbers. Positive or negative 1, positive or negative 1/3, positive or negative 2, or positive or negative 2/3. In a few minutes, we're going to do a couple examples, and this will hopefully make a little bit more sense. But we're going to go ahead for now and move on to the next section. So 5 says to fill in the blanks to complete example for each rule. So we have some rules. The first rule says a polynomial function with degree n has at most n unique roots. So that means if I had a polynomial with third degree, that's going to be something that's written in the form of x cubed. That means it has at most 3 unique roots. So if I had a polynomial that was in the form of x to the 4th, it could have at most 4 roots. If I had a polynomial that was x to the 10th, that would mean it could have at most 10 roots. So whatever the biggest exponent is, that's how many roots it can have. So remember that the degree is the biggest exponent. Okay. The second thing says if a plus the square root of b is a root of a polynomial, then a minus the square root of b is also a root. And this just really comes in handy because that tells you that if you know that 3 plus square root of 2 is a root, then you also know that 3 minus the square root of 2 is a root. And the same thing is true with imaginary numbers, that if a plus bi is a root, then a minus bi is a root. So if we know 4 plus 1i is a root, then we know that 4 minus I is also a root. So how to factor polynomials. Again, we're going to practice this in just a second. First, it says to find all the possible roots. And it tells you that if the leading coefficient is 1, just find all the factors of the constant term. The constant term is just the number. If the leading coefficient is not 1, then we can use our rational root theorem, which is our p's and q's. And again, we're going to practice that. And then we can always use synthetic division to test the roots. A root that works, remember, is a remainder of 0, gives a reduced polynomial for the quotient. And you factor that quotient or use the quadratic formula to find the roots. And then you can use all the roots to rewrite the original polynomial as a product of its factors. So the whole point of this is that we're going to be taking polynomials like this one here, x cubed plus 4x squared minus 19x plus 14, and we're going to be factoring that like we've been factoring everything else. We're going to be breaking it down into smaller pieces. So we're going to try this one, x cubed plus 4x squared minus 19x plus 14. So my rational root theorem will help me figure out where to start. So the rational root theorem says I take all the factors of 14 and divide it by all the factors of 1. Well, my factors of 14, I can divide 14 by positive and negative 1, positive and negative 2, positive and negative 7, and positive and negative 14. 1 is really only divisible by 1. And when you divide by 1, you get whatever you had before. So I have 8 possible factors. So since I have 8 possible factors, I'm going to pick one of them and I'm going to try synthetic division. I'm going to try the factor x plus 1. So that means for synthetic division, I'm going to do -1 and then my division symbol. My coefficients are 1, 4, -19, and 14. So I'm going to bring down my 1. -1 times 1 is -1. 4 minus 1 is 3. -1 times 3 is -3. -19 minus 3 is -22. -1 times -22 is +22. And 14 plus 22 is 36. So since this is not 0, that tells me x plus 1 is not a root. So I can take off that one. Well, then I'm going to try the next option of x minus 1. So I'm starting over using synthetic division again, except this time I'm trying it with x minus 1, so I'm going to put a +1 in front. Underneath the radical, I still have 1, 4, -19, and 14. So I'm going to bring down my 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. -19 plus 5 is -14. 1 times -14 is -14. And I get 0. So what I've now learned is that x minus 1 is a factor. And when I divide it by x minus 1, I'm left with 1x squared plus 5x minus 14. So then I'm going to start synthetic division all over again, except this time I'm going to just be utilizing this factor, the x squared plus 5x minus 14. So I'm going to rewrite that up here. So x squared minus 5x minus 14, plus 5x. So I know that minus 1 worked. Now I'm going to try -2 and see what happens there. So I'm going to do -2. I'm going to try x minus 2. So that means that I need to do a +2 in front of my symbol. And underneath the radical, I have 1, 5, and -14. I'm done with this because I've already reduced it and I've come up with 1x squared plus 5x minus 14. I'm going to bring down my 1. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. -14 plus 14 is 0. So what I've learned is that x minus 2 is also a factor. And what this tells me is that 1x plus 7 is my remaining part, my dividend. So it has to be my last factor because I can't reduce that anymore because there's no way to get rid of anything. So my 3 factors are x minus 1, x minus 2, and x plus 7. And I know that x cubed plus 4x squared minus 19x plus 14 is the same thing as saying x minus 1 times x minus 2 times x plus 7. So looking at a few problems off of our practice, number 1 says to find f of -3. When you read this notation, all this means is to plug in the number. You're just plugging it in. So that means I'm replacing x with -3. So I have 2 times -3 squared minus 5 times -3 minus 8. And if I start doing some math, well, -3 squared is 9 times 2 is 18. -5 times -3 is positive 15 minus 8. And 18 plus 15 minus 8 is going to give me 25. It doesn't ask this, but I'm going to say that x plus 3 is not a root. And the reason I know it's not a root is because I did not get 0 here. So for 3, I'm supposed to find f of 3. So again, I'm plugging this in for x. So I have negative parentheses 3 cubed plus 4 times 3 squared minus 2 times 3 plus 6. Well, 3 cubed is 27. I'm supposed to make it negative. 3 squared is 9 times 4 is 36. Negative 2 times 3 is negative 6. And then plus 6. So if I start doing my math, negative 27 plus 37 minus 6 plus 6 is going to give me positive 9. So that would be my answer. That also tells me that x minus 3 is not a factor. Remember, if I get 0, that means whatever the opposite of this is a factor. So for 4 through 10, we're supposed to factor the polynomial completely. So we're going to use synthetic division. We're going to do number 5. So we're going to start off by listing our p's and q's. It's always our first priority is our p's and q's. Our p's are our factors, in this case, of negative 8. Our q's are our factors of 1. Well, 8 can be divided by positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 8. Can't really divide 1 by anything but 1, so that means I only really need to focus on my numerator here. So I'm going to pick a number at random. I'm going to start with positive 1. So I want to find out, is x plus 1 a factor? Well, if it is, then when I do negative 1 outside my division symbol, I'm going to have 1, 5, 2, and negative 8. And I'm going to do my synthetic division. Bring down my 1. Negative 1 times 1 is negative 1. 5 minus 1 is 4. Negative 1 times 4 would be negative 4. 2 minus 4 is negative 2. Negative 1 times negative 2 is positive 2. And negative 8 plus 2 is 6. Negative 6. So that means this is not a factor. So that's out. So I'm going to try this time. Let's try x minus 1. We're going to see if it's a factor. So I'm going to put positive 1. Then I'm going to do my division symbol. Underneath there, I'm going to put 1, 5, 2, and negative 8. So I bring down my 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 2 plus 6 is 8. 1 times 8 is 8. Negative 8 plus 8 is 0. So I know that x minus 1 is a factor. And this leaves me with 1x squared plus 6x plus 8. And I'm going to try synthetic division again. So this time I'm going to pick a different number. I'm going to try positive 2. So we want to find out, is x plus 2 a factor? So I'm going to do negative 2, then my division symbol. And underneath there I now have 1, 6, and 8 because I now have to go with my numbers that I just got in the previous example. So I'm going to bring down my 1. Negative 2 times 1 is negative 2. 6 minus 2 is 4. Negative 2 times 4 is negative 8. 8 minus 8 is 0. Since I got 0 here, that meant x plus 2 was a factor. And it also tells me that this is my last factor, x plus 4. So when it asked me to factor this problem completely, so my answer would be x minus 1 times x plus 2 times x plus 4. That would be the complete factorization. Don't forget, when you do a problem like number 6 as x cubed minus 7x minus 6, there is no x squared here, so when you do your synthetic division, you have to put a 0 in there as a placeholder. Do not forget that. Number 7, supposed to do synthetic division again. X cubed plus 5x squared minus 2x minus 24. So I'm starting off with my p's and my q's. My p's are my factors of negative 24. My q's are my factors of 1. Since the factors of 1 are just 1, and when I divide anything by 1, I get what I had before, I'm not even going to worry about that. My factors of negative 24 are positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 4, positive and negative 6, positive and negative 8, positive and negative 12, and positive and negative 24. So this time I have a lot of options to choose from. So it doesn't really matter where you start, just pick one and see what happens. So I'm going to start off with x plus 1. I want to find out if that's a factor, so I'm going to do negative 1. My division symbol, I have 1, 5, negative 2, and negative 24. I'm going to bring down my 1. Negative 1 times 1 is negative 1. And 5 minus 1 is 4. Negative 1 times 4 is negative 4. Negative 2 minus 4 is negative 6. Negative 1 times negative 6 is positive 6. Negative 24 plus 6 is negative 18. So obviously x minus plus 1 is not a factor. So we can move on and try the next one, x minus 1. So I'm going to put positive 1, then my division symbol. And I have 1, 5, negative 2, negative 24. Bring down my 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. Negative 2 plus 6 is 4. 1 times 4 is 4. Negative 24 plus 4 is negative 20. So x minus 1 is not a factor. So I'm going to try x plus 2 next. So that means I'm going to do negative 2, then my division symbol. 1, 5, negative 2, and negative 24. So I'm going to bring down my 1. Negative 2 times 1 is negative 2. 5 minus 2 is 3. Negative 2 times 3 is negative 6. Negative 2 minus 6 is negative 8. Negative 2 times negative 8 is positive 16. Negative 24 minus 16 is negative 8. So still not a factor. So next, I'm going to stop trying 2 because that didn't work out. So I think I'm going to try 3 this time. So I'm going to try x plus 3. So if I'm going to try 3, then negative 3 is going to go outside. So I'm going to bring down my 1. Negative 3 times 1 is negative 3. 5 minus 3 is 2. Negative 3 times 2 is negative 6. Negative 2 minus 6 is negative 8. And negative 3 times negative 8 is positive 24. And negative 24 plus 24 is 0. So I finally found a factor. It was x plus 3. So I have 1x squared plus 2x minus 8 left over. So I'm going to have to do synthetic division again with that. So I have 1, 2, and negative 8. So I'm going to go ahead and try x minus 2 as a factor. Plug in my 2 there. Bring down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. So this one was also a factor, and that left me with 1x plus 4. So my last factor is x plus 4. So my final answer to this problem would be x plus 3 times x minus 2 times x plus 4. That would be my factors of x cubed plus 5x squared minus 2x minus 24. Last but not least, problem 9. So I've got to list my p's and q's to begin with. Well, again, this q here is 1, so I'm not really going to worry about that. I'm just worried about my p's. My factors of 21 are positive and negative 1, positive and negative 3, positive and negative 7, and positive and negative 21. So I don't really want to have to go through the hassle again of actually determining which of these is going to work by synthetic division. So what I'm going to do first is we learned the remainder theorem. And the remainder theorem says if I plug the number in and I get 0, then it tells me if it's a factor or not. So the x plus 1 being my first factor, x minus 1 is my second, x plus 3 is my third, x minus 3 is my fourth option, x plus 7, x minus 7, x plus 21, and x minus 21. So what I'm going to do is I'm going to plug in these numbers over here, well, the opposites of those numbers actually, and see if I get 0. So I'm going to try negative 1 cubed plus 5 times negative 1 squared plus 13 times negative 1 plus 21. And if it were me, I would literally just put every bit of this in my calculator. And when I do, I get 12, which in fact is not 0. So x plus 1 is not a factor. So for x minus 1, I'm going to do positive 1 cubed plus 5 times 1 squared plus 13 times 1 plus 21. Well, when I do that, I'm going to end up with 40. So again, not a factor. So for x plus 3, I'm going to plug in negative 3 cubed plus 5 times negative 3 squared plus 13 times negative 3 plus 21 and see what I get. And I'm going to end up with 0. So I know that x plus 3 is a factor. So I can continue this pattern, or I can do synthetic division. I'm going to go ahead and do synthetic division just to kind of help us out a little bit and make this a little bit smaller. So if I know x plus 3 is a factor, then I know that when I do negative 3, and I plug in my numbers, 1, 5, 13, and 21. Well, I'm going to bring down my my 1. Negative 3 times 1 is negative 3. 5 minus 3 is 2. Negative 3 times 2 is negative 6. 13 minus 6 is 7. And then negative 3 times 7 is negative 21. And 21 minus 21 is 0. So I end up with 1x squared plus 2x plus 7. Here's the thing. This can't be factored because there's no factors of 7 that will also give me a 2, but it can't be factored. So my only factor, linear factor, is x minus 3. I'm sorry, x plus 3. And the other half is x squared plus 2x plus 7. You could have continued to plug in each of these numbers. You could have done 3 cubed and plugged in 3, then negative 7 cubed and plugged that in, then positive 7 cubed, then negative 21 cubed, and then positive 21 cubed. And what you would have found is none of the other ones are going to give you 0. The only one that's going to give you 0 is that x plus 3.